Segmented worms. Finally, an animal we recognize. These are of the phylum Annelida. Annelida just means a segmented body. Examples include earthworms, leeches, and of course, gummy worms. See the segments? Yeah. So, I bet you never really thought about leeches as a worm, but that's what they are. They're segmented worms. You can see the little segments on their bodies. Let's take a minute to talk about leeches. I love leeches. There's something different about them compared to all the other parasites that we've talked about so far, in that they're external parasites. And what's so interesting about that to me is if you're an external parasite, you're big. You're not tiny. You don't have any easy way to get into the body, so you have to stay outside. And they latch onto you, bite you, and suck your blood. Now, how are they going to do that without you noticing? Well, they have two adaptations for that. The first is an anticoagulant. That is something that keeps the blood from clotting. And by doing that, they can keep their food source flowing into their mouth instead of scabbing up where they can't get any of it. The other thing is an anesthetic, which is something that kills pain. So their saliva actually numbs the localized area of your body where they're going to bite before they do. And then they bite you and you don't even feel it because of that anesthetic. Now, why I think this is so cool is because we as humans have found a way to capitalize on this characteristic of leeches. We use leeches often in surgery, where we literally put the leeches on a surgical incision to keep blood from flowing in situations where having a scab on the incision would be problematic. They're also useful as a mild anesthetic for certain procedures. Now, we don't use them that often. It's a pretty antiquated method, but there are times when they have to bring out leeches to do surgery. And I just think that's so fascinating that we found a way to capitalize on this natural parasitic nature of the leech. But enough about that. Let's talk about the advancements that we've made going from a roundworm to a segmented worm. The big one is the segments themselves. They lead to more movement, really a greater degree of movement, and they have more advanced organs. If you take a look here, I've put up pictures of some of these. We're not going to get into a lot of these in a whole lot of detail, but as you can see, things have gotten very complicated inside of our worms' bodies. And if we look over here, we can get a view of their intestines. Now, I do want to take a minute to talk about the worm intestines, because it's another advancement that I think is just so fascinating. So take a look at this. Worms, specifically earthworms, spend a lot of their time in the dirt. And that's actually where they get their nutrients from. They eat the dirt. It passes through their intestines, and as it does, they get nutrients out of it. They suck the nutrients out of the dirt. Organic matter is coming out, in other words. So in order to maximize the amount of nutrients you're going to get out of it, what can you do? Well, there are two big adaptations that the worms have come into. The first is to just be longer, because that way the soil spends more time in contact with your body, and so more nutrients can be sucked out. The other one that I think is just so clever is that they have this fold inside of their intestines. Now, you would expect that a worm intestine would just be round, because they're round. They're like a big cylinder. But no, it has this fold in it. And what that does is it increases the surface area of the entire intestine. And as such, there's literally more contact with the dirt. And if there's more contact with it, then they can suck more nutrients out while it's in their body. Isn't that just fascinating? Now, worms are monoecious. Remember, we talked about, segmented worms are monoecious. We talked about how the roundworms were dioecious. Well, now we're back to it, which means that they are both male and female in the same organism. They have both a seminal vesicle and receptacle. The vesicle secretes semen. The receptacle has eggs in it. It takes up the semen and gets fertilized. And these are both present in the clitellum. Now, what is the clitellum of a worm? Well, it's this right here. Yeah. Now we have name to the face, so to speak, right? This is the clitellum of a worm, and it's where they do all of their mating, which is kind of awkward, but that's worms. You gotta let the worms worm. Now, finally, I'd like to talk about the heart of the worm. Or should I say, the aortic arches. Worms are complex enough to have a circulatory system, and it looks kind of, I'll say, much different than ours. But these are hearts, so to speak. The aortic arches function to pump blood throughout the body and then come back to be oxygenated. They're a lot simpler than our hearts are, but they have 5 of them where we only have 1, so take that. This has been the lecture on worms.